The variables that we have discussed so far are all scalar variables. That is, they can be assigned only one value. It's often useful to use array variables, which can be assigned multiple values. Arrays act basically like vectors or even matrices. There are several good reasons to use arrays rather than scalar variables. One purpose of using arrays is to organize information. So, for example, each array element might correspond to a thermodynamic state in a system that's being analyzed. Also, mathematical operations that are common to each element of an array can be performed easily using the duplicate command in ease, which will be discussed subsequently. This is particularly convenient when developing numerical models. Finally, information in arrays can be used to generate plots. The variable tscalar, which is assigned here, has only one value. The value and the units of the variable can be examined in the solution window. Arrays are ease variables that have one or more array index enclosed in square brackets at the end of the variable name. So here the array tarray consists of three separate variables, tarray1, tarray2, and tarray3. The value in square brackets is the index of the array. Therefore, tarray1 is the first element of this array, and so on. The values in the variable tarray will be stored in the Arrays table window, which can be accessed by selecting Arrays from the window menu. The array variables tarray1, 2, and 3 behave just as normal, ordinary ease variables in that they have units, they can have limits, guess values, etc. A convenient shorthand method for referring to multiple array values uses the array range notation. A continuous range of indices in an array can be referred to by the first index and the last index separated by two dots. So, for example, tarray1 ... 3 could be used in place of tarray1, tarray2, and tarray3 separately. Array range notation can be used in a variety of contexts, including assignment statements. Note that ease expects at least the correct number of values, 3 in this example, to exist within the square brackets on the right side of the equation. Otherwise, it'll post an error. If more than 3 values were provided in the square brackets, then the first 3 would be used and ease would post a warning. The duplicate statement provides a convenient method for carrying out similar operations on multiple elements of an array. The protocol for using a duplicate statement is shown here. The variable index is iterated from the value start to the value stop. The equations that are contained between the duplicate and the end statements are written for every value of the variable index. For example, the ease code shown here is exactly equivalent to writing the 4 separate equations shown here. When using duplicate statements, it is particularly important to remember that ease uses equations rather than assignments. That is, do not accidentally place an equation within a duplicate statement if you don't actually want that equation to be duplicated for every value of the variable index. A common mistake that ease users can make is shown here. So this code is exactly equivalent to writing this set of code here, which leads to 8 equations in 5 unknowns, and solving this ease code will lead to an error message. Nested duplicate statements can be used to generate two-dimensional arrays. For example, the code below leads to the two-dimensional array that is shown here. Ease saves every variable that you introduce as you develop your program. And this is usually very helpful because you want to be able to temporarily remove variables without ease forgetting what units, guess values, limits, and so on that it has. However, saving every array variable can sometimes be inconvenient. So for example, if you start your program with an array X that contains 500 entries and then later change its name to Y, ease will retain in memory both X and Y for a total of 1,000 variables. Similarly, if at some point your array X is defined with 2,000 entries, but later on you reduce its size to only 500 entries, then ease will retain in memory all 2,000 variables. Clearly, you can easily introduce many variables using arrays that you do not ultimately wish to use. In order to clear variables from memory, you must use the purge unused variable command from the options menu. at which point ease will check if there are any unused variables in memory and ask whether you want to purge or keep them. Solving the ease code here generates a 50 by 50 two-dimensional array D. The ease program therefore includes 2502 variables. That is all of the entries in the array D as well as the variables nx and ny. So now let's reduce the values of the variables nx and ny as shown here in order to generate a 10 by 10 array. Solving reduces the number of active variables to only 102. Because ease retained the original 2502 variables in memory, there are currently 2400 unused variables. In order to purge these variables and reduce the size of the ease file, select Purge Unused Variables from the Options menu. You will then be asked to confirm that you want to purge the unused variables. One of the most useful features of arrays is that they can be plotted. And this then allows state points that are stored in arrays to be placed onto property plots. And that's the subject of our next video.